Thank you. I'm going to talk about OCaml 403 and also a little bit about 404.
Please don't announce multi-core. That was very bad news.
I'm sorry, it's already on the slides. As usual, this is joint work with a bunch of people, and they didn't fit on this slide, so... So there was only one release since the last OCaml workshop, and that is 403. It was released in April. The main feature of 403 is F lambda. It's really the elephant in the release. We also have ephemerons, which are pretty important, I think. There are two new backends. So usually we remove backends for obsolete architecture. Now we have two new ones, 64-bit PowerPC and IBM Z Systems, which is the latest name of the latest iteration of the mythical IBM 360 mainframe architecture. There's lots of bug fixes and feature witches and quite a number of performance improvements, which range from small to quite large. Let me tell you about F lambda. This is the work of Pierre Chambard and Mark Shinwell.
And Leo.
And Leo, oh, sorry. Sorry, Leo. Is Leo here? He's not here. And Leo White, so. What is F lambda? It's a new intermediate language in the compiler. It's a bunch of optimization passes for this intermediate language. I've listed just a few of them. It is 43 modules in the compiler source, new modules, which comprise 16,000 lines of code. It's a configure flag and the new OPAM switch, which you can try right now if you have network connectivity. It introduces 21 new command line flags to control all the optimizations. And what it gives you is better performance for your programs and unfortunately worse compilation times, which Pierre is working on right now. Unfortunately, it's a bit of an experimental feature, and that's why it's a configure flag. You cannot mix files compiled without F lambda and files compiled with F lambda. But thanks to OPAM, that's not a big deal. Oh yes, okay, so Yaron Minsky has a great blog post about inlining and specialization and unboxing and why they matter for serious programs. So instead of repeating what he said, I'm going to try to convince you that F lambda is magic by using a small example on branch merging. So this is my example. It's a kind of inventory system for fruits. So a shipping of fruits, for example, can be apples with a number of apples, it's an integer, and their color, or oranges with the number of oranges, and we don't need their color because oranges are all orange. Or bananas with the number of bananas and the curvature. Yeah, the European Union has a rule about the curvature of bananas. That's true. So if we want to know the number of fruit in a shipment, this is the function we are going to write. It just does the pattern matching. If it's apples, then return the first argument of the constructor. If it's oranges, return the argument of the constructor. And if it's bananas, return the first argument of the constructor. So if you're a low-level minded hacker, you're going to say, oh, this is insane. What this is doing is get the value, test the tag, and if the tag is 0, return the first field. If the tag is 1, return the first field, and if the tag is 2, return the first field. So I can do better than that, just don't test the tag, right? So I'm going to write this. So, okay, if you write this, you're going to get yelled at for using obj, and rightfully so. But you can hope that it's faster than the other function. So let's have a show of hands. Who thinks that the second function is faster than the first? Fabrice. Come on, raise your hands. Okay, there's a few people who think that. Who thinks that they are the same speed? Yeah, there's a few people too. And who thinks that the first one is faster? Yeah, about the same number of people, so it's 1/3 each. So let's look at what the compiler generates. I took the CMM instead of the assembly because it's shorter, it fits on the screen. And I took it instead of the lambda code because it's clearer what's going on. So the first function is the bottom one here. And what it does is take the parameter and return the first field. That's f lambda at work. Yes? I tried. This is actual output from the compiler. And the second one is the one up there, and what it does is load unsigned int plus a f15 whatever. Actually what this does is look at the tag and compare it with 254, which is the tag for arrays of floats. If it's not an array of floats, then you load the first field. If it is an array of float, you do a lot of things because you have to allocate the float and so on and so forth. So that last line is dead code, but it's still there. It's 12 instructions in the assembly, and just doing the test and so on is 8 instructions. The one produced by f lambda is completely optimal. It does load and return. So if you're the kind of people who write the bottom function, the second function, I forgot to change the names, but then you can relax and write the first one and know that f lambda is doing an even better job than you at optimizing it. And if you're the kind of people who stay away from obj, I hope that's the majority, you can go on writing the first one and know that f lambda is now optimizing your program quite well.
Are you sure it's specific to f lambda? Because I have tried on 402 and I have exactly the same result.
Ah,
Lambda.
Is that true?
Yeah, it was optimized before.
Oh, I'm surprised.
And pattern matching
I'm sorry. So it was. So Fabrice's remark is that it's not specific to f lambda. But anyway, so my example is bad, but it's the kind of low-level optimization that you can expect from f lambda, right?
You get that with more complex expressions.
Okay, so f lambda, so the old compiler can do it in this function, but f lambda can do it in more functions. Sorry for the bad example. So anyway, the point of f lambda is that you can write your code here with modules and abstractions, and f lambda sees through all those, and it does cross-module inlining, and then a lot of the optimizations that are enabled by inlining. So the other novelty in 4.3 is ephemerons. I'm not going to talk a lot about ephemerons because they were already presented 2 years ago in this workshop and 5 years ago in the Paris meeting. But now they are in the compiler, or in the runtime system, in fact. So if you're a user of weak pointers and you have been frustrated by their behavior and trying to memorize functions, in fact, with weak pointers, ephemerons are exactly the thing you need. They generalize weak pointers, and so yeah, I'm going to say what they do. An ephemeron is a number of weak pointers and then a data pointer, which is a conditional strong pointer. strong because even if it's the last pointer to the value is not erased by the GC, still live. But it's conditional because the GC will erase this data pointer as soon as it erases one of the keys. And it turns out that's exactly what you need for memoizing functions. Yeah, so go back to François' presentation 2 years ago, and he explains everything. There are other new things in 4.3. I've listed them here. So gedt's got better. We can write constructors as arguments, records as arguments of constructors. And that allows you to do more efficient data structures. And in fact, this is used, I'm not sure if it's in 4.3 or 4.4. This is used to optimize queues and another module of the standard library while removing while removing uses of obj in those modules. So it helps you write efficient data structures. The point here is that the record that's an argument that can only appear as an argument of this constructor, it can have mutable fields. So we have constructors with mutable fields. Another kind of thing that helps you optimize your programs is the immediate annotation. This is a kind of contract. It says, I promise that this will ultimately be implemented by an integer or a concrete type with only constant constructors. So all the values will be at runtime represented by integers. And then the compiler, that's one part of the contract, and the other part of the contract is that the compiler can use this information to optimize uses of this type, especially removing the write barrier of the GC and stuff like that. We have marshalling of large values, large meaning more than 4 gigabytes of marshaled data, of the output file, in fact, which is so you need quite a lot of memory to produce that, but we do have users who do that. We have GC pause time improvements, which means that the GC will not stop your program for quite as long as it did before. So you might not have noticed, but if you do a program that must react fast to some kinds of events, then it's a big deal. And it finally solves one of Fabrice's bug reports, which was that the marking of a large int array was making a big pause in the program. That's solved 10 years later. We have colors in compiler warnings and errors. That's not very interesting from a theoretical point of view, but it's a big usability improvement, in fact, because those messages just stand out in the output. There are many small syntax improvements. I cannot list all of them, but I was surprised reading the changelog, how many there are. Because usually every syntax change starts a big fight. And we have additions to the standard library. So a UChar module, which is for Unicode characters. So hopefully that will unify the baseline for the various Unicode libraries that exist. And the result type, which is an alpha beta result, is OK of alpha or error of beta. which everyone was redefining, so now you can use the standard one. And there are also a relatively large number of new functions in the standard library, actually. So we used to say, oh, the standard library doesn't change, but in fact it does. Well, these are my co-authors for the everyone who contributed to 4.3 is listed here, so if you don't find your name, come to me and complain. Too late. One word about the release process. 4.3 was quite painful to release, and 4 months behind the schedule that I expected, in fact. I don't think it was really announced, but and so we are switching to another way of doing release. It's just every six months, just take whatever you have in trunk, and that's the release. Of course, there's some debugging to do. So every 6 months, I just freeze the features and branch the trunk, and we release, we debug and release that. 4.4 is the first release with this new process. It was frozen in August, and 4.5 will be frozen exactly 6 months later, I hope, in February. So you can expect 4.5 to be released somewhere in maybe April next year. Oh yes, okay, maybe I should talk about 4.4. It's not released yet, but it's just around the corner. So early October, I think. It features one large new feature, which is the space-time profiler. It's a memory profiler that will tell you everything you need to know about your programs, or about their memory behavior anyway. And smaller things like local exceptions. OCaml Lex works correctly with safe string. Very small thing like installing instead of installing by default the bytecode version of the tools, now we install by default the optimized version of the tools. So your compiler is going to run faster. And more optimization, and especially quite some work on F-lambda, right? And further down the line, we have, that's for some future version that's not specified, some future versions that are not specified. I hope we will have modular implicits and algebraic effects and multi-core OCaml relatively soon. So in closing, I would say enjoy OCaml 4.3 and soon 4.4. Try to port your code to safe string mode. One day it might become the default. Actually, I copied this sentence verbatim from Xavier's slides of 2 years ago. So let me make a small change. You should do it now, because I'm thinking of making safe string the default for 4 or 5. Yes?
There is more to it than the default. Jeremy wants it to become hereditary, so that when you have a module with safe string, and someone wants to use it, they also want to use safe string. And if that change goes, it will become de facto the default. I mean, people will have to work with that or have a separate switch with no safe string.
So what Gabriel is saying is that it's not just about being the default, but someday it will become in fact mandatory, because you will not be able to link unsafe with safe in your programs. As usual, you should contribute packages to OPAM. Every OCaml piece of code should be in OPAM. And if you want to contribute, this is the place. Thank you for your attention.
Any questions?
No questions.
You have a date for 404?
Do I have a date for 4.4? Very soon.
Very soon we have the date.
No. No, we are ironing out the last bugs in 4.4, so no more than 2 weeks, I say. Don't quote me on that.
Is anyone actively working on the modular implicits?
Is anyone actively working on the modular implicits? Yes. 2 people right here in Japan, so.
I have a comment to make. In 4.3 and 4.4, some of the bottlenecks for the release were that we didn't have enough people reviewing code. We had a lot of people contributing new pieces of code to integrate, that was cool, but not enough people reviewing code. So please go to GitHub, pick a random pull request, and review it tomorrow. That will be very, very helpful. You need more of that.
So Gabriel's remark is many people contribute, but we are a bit short on reviewers. So if you can do a code review or 2, that will be good for everyone.
How has the move to GitHub gone in 1 year?
I'm sorry?
The shift to GitHub, has it been useful?
Has the shift to GitHub been useful? Yes, absolutely. GitHub is a very good tool, in fact, yes.
Okay, let's thank the speaker.